All right, welcome to The Explainer. Today, we're going to get our hands dirty and talk about taming the wild world of microservices. We're going to look at how you can take all that controlled chaos and manage it using two really powerful tools, Protobuf and Kong. So, picture this. You've done it. You've embraced the microservice architecture. Your big app is now a collection of small, independent services. It's awesome. It's scalable, it's flexible, but now you've got a totally new kind of problem. How in the world do you get all of these things to work together without creating an absolute tangled mess? Right? And the very first piece of that puzzle is communication. You have to get all of your separate services talking to each other. And not just talking, but doing it reliably. And maybe even more importantly, doing it super efficiently. You know, when all these little services are zipping data back and forth, even a tiny misunderstanding can cause bugs, crashes, and you know what that means? A lot of late nights spent debugging. It's absolutely crucial that what one service sends is exactly what the other service is expecting to get. Now, a lot of us, we default to something like JSON. And hey, it's great. It's easy for us humans to read, it's flexible, which is perfect for web APIs that talk to the outside world. But for that high-speed internal chatter between your services, that flexibility can actually be a huge weakness. You need something stricter, something way more performant. And that, my friends, is where protocol buffers, or protobuf, really starts to shine. So this is where the first part of our solution comes in. We need to create a universal translator, a common language that every single one of our services can speak, and speak fluently. So what is protobuf? Well, think of it as a super strict blueprint for your data. It's a format that Google came up with, and it's not based on text like JSON is. It's based on a really compact binary code. And the most important part is that it forces you to define a rigid structure, a schema that acts like an ironclad contract between all of your services. So, why is this so cool? Well, first off, it's built for speed. The data is way smaller, so it processes much faster. Second, that strict schema acts like a bodyguard for your data, swatting away errors before they can even happen. Third, it doesn't care what language you use. Your Python service can talk to your Java service, which can talk to your C++ service, no problem. And finally, you can actually update these data structures without breaking all your older services. It's fast, it's safe, and it's incredibly versatile. Okay, theory is great, but what does this actually look like in the real world? Let's imagine for a second that you're using a system like Kafka to stream data between all your services. The whole workflow is actually pretty straightforward. It's basically a four-step dance. First, you define that blueprint, your schema, in a special .proto file. That's your contract. Second, you run a compiler on that file, which automatically spits out code for you in whatever language you need. Third, the service that's sending the data, the producer, uses that new code to serialize its data into that compact binary format. And finally, the service that's receiving it, the consumer, uses the exact same code to deserialize it back into a perfect, ready-to-use object. And here's the magic on the sending side. This little method right here is at the heart of it. The producer calls something like .serialize to Chukaching, and bam, its data is instantly packaged up into that efficient binary format, all ready to be sent across the wire. And then, on the flip side, the consumer does the exact opposite. It grabs that incoming binary message and just calls .parse from string, and just like that, it unpacks the data, perfectly recreating the original information, all thanks to that shared blueprint. And just like that, success. Our internal communication is flawless. Data is flowing fast, it's safe, it's reliable. But you know how it is in tech, right? You solve one problem perfectly, and all you've really done is reveal the next, even bigger problem waiting for you. So let's move on to that next big hurdle. We've cleaned up the inside of our house, but now we got to deal with everybody trying to come in the front door. Okay, so our internal house is in order, but what about the outside world? What about all the requests coming from users, from mobile apps, from other companies' systems trying to integrate with yours? How do they talk to your services? This right here, this is what happens without a plan. It's a total mess, a microservice maze. The poor client has to know the specific address for every single service, the security rules for each one. It's messy, it's insecure, and it is a complete nightmare to try and manage or scale. So how do you fix this maze? You need a front door. You need a bouncer for your whole system, someone who checks IDs, knows who to let in, and knows exactly where they're supposed to go. And boom, look at that difference. This is what it looks like with an API gateway like Kong sitting out front. It's clean, it's simple. The client only needs to know one single address. From there, the gateway is smart enough to route every single request to the right internal service. So, what exactly is an API gateway? Well, you can think of it as a traffic controller or a reverse proxy that sits right in front of all your microservices. It's the single point that accepts every incoming API call, and then it figures out where to send it. It's basically the front desk for your entire application. And the benefits here are, well, they're huge. You get one central place for routing. You get load balancing, so traffic gets spread out evenly and no single service gets overwhelmed. You can handle all your security, like SSL certificates and authentication rules, right there in one spot. Plus, you get a single dashboard for monitoring all your traffic, and you can even do things like caching to speed up responses. The big takeaway is this: an API gateway gives you control, security, and visibility over your entire system. Okay, so let's recap. We've got our common language, protobuf, and we've got our single front door, Kong. Everything's perfect, right? Well, what happens when that blueprint, that protobuf schema, needs to change? How do you manage different versions of your data across dozens of surfaces without everything just breaking? Well, that's a whole other puzzle, and definitely a story for another explainer.